Hello everyone, I am Dr. Rajesh. I welcome you in this video lecture, and in this video lecture we will study Leibnitz theorem for nth order derivative. And what does that theorem state? It states that if u and v are two functions of x having nth order derivatives, then the nth order derivative of their product u into v, and suffix n denotes nth order derivative, is equal to nc0 u naught, or you can write it as first un v naught plus nc1, decrease this by 1, un minus 1, increase this by 1, u1, plus nc2 u n minus 2 v2 plus n c3, decrease it by 1 v3, and so on. You will write n minus r, this will be u n minus r minus 1. So what it will be? Minus r plus 1. This will be minus r plus 1, and here will be same v r minus 1. ncr u n minus r vr, and this will go on, and the second last term will be n c n minus 1, and this will be u1 v n minus 1 plus n c n u naught vn. Fine, where suffix or subscript denotes nth order derivative. Fine. So this is how you give the statement of Leibnitz theorem. Now we will be carrying out its proof. So we will be doing it by principle of mathematical induction. We shall prove the result by principle of mathematical induction. For n is equal to 1, we will be having uv 1 is equal to, apply the product rule, do the differentiation of u first, u1 v as such, u as such, differentiation of v means v1, and here is 1 can be written as 1c0 u1 v, and here it can be written as 1c1 u v1. Fine. For n is equal to 2, so this implies result holds good for n is equal to 1. For n is equal to 2, uv 2 is equal to, differentiate it 2 times, uv 1 and 1. uv1 is equal to u1v plus uv1 from the above result. Differentiate it again. Apply product rule. First function, second function, first function, second function, and you are required to maintain the symmetry. Every time I am differentiating u first. So throughout the question you will maintain the symmetry. So once again I am going to differentiate u first, u2, v as such, now u1 as such, v1, plus here differentiate u first, u1, v1, now u as such, v2. This will form u2v plus 2 u1 v1 plus u v2, and here zero order derivative is v itself. So here if we write v naught it would be right, and here if we write u naught it would also be right. So now this is the case. This is further equal to 1 can be written as 2 0 u2, and in place of v we can write v naught, plus in place of 2 we can write 2c1 u1 v1, because we know 2c1 is equal to 2. Fine. Plus 2c1 2c0 2c1, and it is 2c2. 1 is equal to 2c2 you can write, and instead of you will write u0 v2. So here result is holding good for n is equal to 2, implies result holds good for n is equal to 2. Now let us suppose that result holds good for n is equal to k. That means uv k is equal to c k0 u k v0 k c1 u k minus 1 decrease by 1, increase it v1 k c2 k minus 2 v2 k c3 u k minus 3 v3 plus, and you will continue it likewise, k r minus 1th term will be u k minus r minus 1, it will be k minus r plus 1, it will be k minus r plus 1, and v r minus 1, plus write the kc r u k minus r v r, plus this will be k c k minus 1 u1 v k minus 1 plus c k k, this will be u naught vk. Now differentiating both sides with respect to x, we get so what will get u v k is already here, so it will be k plus 1. Apply the product rule. and I am maintaining throughout the question among u and v. I am preferring u, and every time I am differentiating it prior to v. So it will be uk plus 1 v naught, fine, plus k c naught uk v1. Now apply the product rule upon this one. Fine. What it will be? K C1 UK V1 plus K C1 U K minus 1 V2. Fine. Now apply product rule upon this one. What it will be? K C2, it will be U K minus 1 V2 plus K C2 U K minus 2 V3. Now apply product rule upon this one, plus K C3 U K minus 2 V3 plus K C3 UK minus 3 as such. Fine. And V3 will be V4. 3 dots. Now differentiation of this one now, plus K C R minus 1 U K minus R plus 2 V R minus 1 plus K C R minus 1 U K minus R plus 1. This will be V R, fine, plus K C R U K minus R plus 1. Apply product rule over here, first function, second, and also we have applied over here. UK minus R plus 1 VR as such, plus K CR U K minus R V R plus 1. Fine. Now next you will apply the product rule upon this one, first function, second, first, second. Now this was the rth and r minus 1th term, r minus 1th, and this is rth term, and this is r plus 1th term. So now we will take the second, last and last. So what will do, you will again write 3 dots plus differentiate it with respect to, it will be K C K minus 1 U2 V K minus 1 plus K C K minus 1 U1, and it's VK. Now this one K CK U1 VK plus K CK, it's U naught VK plus 1. Now we will do the collection of the terms. Look over here, from this and these two terms have common UK minus 1 V2, okay, and these cross terms have common UK minus 2 V3, fine. Similarly, it will somewhere the following term of this one of this will be having UK minus 3V, and it will be here. So you will collect these terms something like this term and this, Similarly this will go on, and this. Fine. And these two terms can be collected. Okay, now I am going to write it as this is further equal to k c naught is 1. Okay, for the timing I am writing it as such: k c naught u k plus 1 v naught plus k c naught plus k c1, and outside is uk v1 plus, now collect these two, k c1 k c2, outside is u k minus 1 v2. Now collect these two terms, k c2 k c3, and outside is u k minus 2 v3. Fine. And now collect these two, plus it will be k c r minus 1 plus k c r u k minus r plus 1 v r, and it will go on, because the term which will be pairing with this one is in the following term to this one. So but it is not written, but it will be having a pair for sure. Okay, for as of now we are collecting only the terms whose pairs are visible to us. So this will be k ck minus 1 plus k ck u1 vk plus k ck u naught v k plus 1. Now this can be written as k plus 1 c naught u k plus 1 v naught plus, and this is equal to, we know the result, that c k r plus c k r plus 1 is equal to c k plus 1 and r plus 1. Increase it by 1 and the greatest of these two integers r and r plus 1 is r plus 1. So applied it over here, it will be k plus 1, greatest of 0 1 is 1, and you have studied this result in 10 plus 1, plus it will be k plus 1 c2 u k minus 1 v2, it will be k plus 1 c3 u k minus 2 v3 plus it will be k plus 1 c r u k minus r plus 1 vr plus k plus 1, apply upon this one, c k u1 vk plus, and this can be written as k plus 1 c k plus 1, and it is u naught v k plus 1. Because we know that k c naught also k plus 1 c naught is 1. Similarly k c k plus 1 c k plus 1 is equal to 1. So this will be the result. Now this can be further written as C k plus 1 0 u k plus 1 v naught plus C k plus 1 c1 u. It can be written as k plus 1 minus 1, okay, plus k plus 1 c2 u k plus 1 minus 2, because k minus 1 can be written something like that, v2 plus k plus 1 c3 u k plus 1 minus 3 v3 plus k plus 1 cr u k plus 1 minus r. 1 is written before r, so it will be k plus 1 minus r. So this will be vr plus k plus 1 ck u1 v. It can be written as k plus 1 minus 1, fine, plus c k plus 1 u naught v k plus 1. This is nothing but u v k plus 1. This implies that result holds good for n is equal to k plus 1. This completes the induction. Therefore, by PMI result holds good for every natural number. So you can prove the result by PMI. So we have proved the result by principle of mathematical induction. We have shown, firstly we have proved it for n is equal to 1 by applying the product rule simply. Then we again did it by applying the product rule 2 times and proving it that it holds for n is equal to 2. Then we assumed that it holds for n is equal to k and assumed these terms. In between we have taken this rth and r plus 1th term, and then it will continue second last and the last term. Then we differentiated it again to form it as with respect to x. So then we collected the terms by applying this result. These results, we have shown that result holds good for n is equal to k plus 1 also. So this completes the induction. Then we can say that result holds good for every natural number. So that is the Leibnitz theorem, which gives the result by which we could find the nth order derivative of the product of two functions. If u and v are two functions of x, then their product will be uv and its nth order derivative can be given by Leibniz theorem. This is the law, this is the principle that the Leibniz theorem gives us. That's all I have from this lecture, and if you like the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye and see you soon. Thank you very much.